Hey guys, okay, so I'm seeing a lot of people currently struggling with partial derivatives, so we're going to go over these and we're going to quickly do all of the partial derivatives that you see in this list on this expression here. So let's start with the first one, d over d phi. So we're going to take the partial with respect to phi of this entire expression. So rule number one, let's look at the variable that we have in our denominator, this phi, and let's see if it's in our expression. So it's not here, and it's not here. Okay. So when it's not in our expression, we basically are treating the expression as a constant. So it's essentially d over d phi of some constant. Anytime we have the derivative of a constant, it's going to equal 0. It might as well, like say for example, of 3 equal to 0. So we're treating it like a number because it doesn't have a variable, because the only quote-unquote variable that we care about is this one when we're doing a partial derivative. Okay? So first one's pretty easy there, just a constant, okay, equals 0, okay, d over dr. Okay, so what have we got here? Let's paste our expression in. Okay, so let's see where we have our r's here. Okay, so we have an r here, we have an r here. We don't have an r in this piece, so it's going to be just like the derivative of a constant. It's going to go to 0. These guys do have r's though, so let's work with those pieces. Okay, dr, and then we can break them up because if they're added together, we can treat them as two different ones. You don't have to break them up if it makes sense to you to just do them right away. Please do. If you are not super comfortable with them, you can do this, but only if they're added. Okay, so let's see here. So here's our r, here's our r. This piece is a constant, and then this 2x to the third is a constant, so we can pull it to the outside, right? Because we're not taking a derivative with respect to that. We're only taking a derivative with respect to r. 2x to the third times the partial with respect to r of r, plus the partial with respect to r of r squared. And we're pulling that cosine out, so partial with respect to r of r squared. Okay, so we took out some pieces, maybe to make it a little less confusing for some people. Okay, so what's the derivative of r with respect to r? It's like the derivative of x with respect to x, you know, just 1. So times 1, and then we have cosine of theta, derivative of r squared to r. Okay, so that's our solution there. All right, you guys with me so far? So we did 1, 2. Okay, so we got this guy and this guy. Well, let's do the derivative with respect to theta. Okay, same expression, derivative with respect to theta of this guy. Okay, let's look for our theta pieces. Okay, so no theta here, so these go to 0, right? 0 and 0. Okay, but we do have a theta here. So we're going to have the derivative of r squared cosine of theta, right? Okay, but this does not have any theta components. We're treating it like a constant, so we can pull it out. R squared cosine of theta. Okay, and the derivative of cosine of theta with respect to theta is just going to be negative sine of theta multiplied by r squared. So that's our answer here. Okay, let's do the next one. Okay, so let's do the derivative with respect to x of this expression. Okay. So derivative with respect to x of this guy. Okay, let's look for our x's. Where are they? We have an x here. Do we have an x here? No. Derivative of a constant, because we have no x's. So dx of a constant equals 0. So again, no x's. So this goes to 0, this goes to 0. Okay, so do we have x's here? Yes, we do. Okay, so we have 2r x to the third. Okay, so this 2r piece we can treat it like a constant, right? Just treat anything that's not x like a number. Okay, this is our only x piece remaining, and we are going to pull our 2r to the outside. Okay, and that's going to equal 2r times 3x squared, because that's just going to be the derivative of x to the third with respect to x. Okay, so that's our answer there. Okay, let's cross that one out. Okay, let's look at the partial with respect to y. So the partial derivative with respect to y, same expression. Okay. Oops, sorry. Okay, so the partial with respect to y. My handwriting is getting worse as I keep going, huh? Okay, partial with respect to y. Okay, do we have a y piece there? Anything y? No. It's a constant. It goes to 0. Anything y? No. Constant goes to 0. Anything y here? Yes, we do. Okay, so let's do that one. Y, z. Okay, so any more constants here that we can pull out? Yes, we can pull out z. Okay, partial with respect to y. And we have a y. So that's just going to be z times 1. Derivative of y with respect to y is just going to be 1. Okay. Next we have the last one, which is the derivative with respect to z. Okay, derivative with respect to z of this guy here. Okay, let's see where our z pieces are. Do we have any z pieces? It looks like we do. Okay, so this one, anything z? No. It'll go to 0. This one, anything z? No. It'll go to 0. Derivative of a constant. Okay, this one, we do have z. Okay, so we have the derivative with respect to z of yz. Okay, y is our constant this time, right? So we can pull it to the outside, and then we just have the derivative with respect to z here. So y times the derivative with respect to z of z is just going to be y times 1, which equals y. Okay, so hopefully that was a good refresher where we kind of got to see a lot of examples and what it means to take the derivative in terms of one variable while treating the rest of the variables like a constant.